graph. If you do read it off the graph, I would go back and plug it in and just double check, right? Because that graph is not easy to read. But now that you have the Reynolds number, you can go in and read it off of the graph. Right. As long as we can get the, right, the epsilon. So what do we do for epsilon?
A table value?
Table value, yeah. So which one did we choose? Did we choose?
Oh,
Worst case scenario?
Worst case scenario. Yeah, we don't really know, right? So it didn't say, the pipe is commercial steel. It doesn't say anything, and it doesn't say what is causing the hole. If it had said that the hole is caused by rust, okay, then I would go with the rusted one, right? But it doesn't say what the hole, what the cause of the hole is. So if we do epsilon is 0.046 millimeter, we choose that because it's worst case scenario. Which means our epsilon over the 0.046 over 50 millimeters. 9.2 and if we go from reading from figure, it's 4-7, we get that F is approximately equal to 0.07. And if we plug this into this equation, which is equation 432, with F is equal to 0.07, gives us F is equal to 0.00726. Seems to be accurate enough, right? Particularly on an exam, right? If you plug this back in into equation 32, you get 2, 3 at the end. So, okay, so let's summarize our KF here now. So we don't have an interest term. We got 2 elbows where we have put in numbers. Actually, let's just take let's look at one at each time and just get the numbers for them. So QF elbows is equal to 800 over 16,411. That's our 25. 1 plus 1 over 97 inches. That is equal to 0.4257. Our pipe term is 4 times R 0.0723, or 3 plus 3 plus 1 meters over 50. That is equal to 4.0488. Okay, so if we put all these numbers into our equation, we have minus P1 gauge over the density, 928 kilograms per cubic meters. Then we have our delta U is 0. We have 9.81 meters per second over GC, which is 1.0 square meters per second squared living, times 3 meters in this case. KF, which is 2 times our elbow term, 0.4257, plus our pipe term, 4.0488, plus our exit term, and then that is times our, I didn't write that anywhere. Here, I forgot something. I should not do that. Okay, remember our F is equal to sum KF times U squared over 2GC. Okay, so please correct that. The F term is not equal to just KF. Okay? The F term is equal to the sum KF, but times the velocity. Okay, so that's what we have. That's what we have down here. We calculated our velocity is 1.415 meters per second squared, and it is 2 times 1.0. Okay, that's our GCA.
Dr. Weaver,
Yes.
in the cat elbow, how do you get rid of the inches there? What, yeah, where does that go to?
It is incorporated in here,
Okay.
right? So just make a note of this too, that the equations have the inner diameter in inches. Okay, so it has to have been incorporated in here somewhere.
So those
right?
constants?
It's fitted, it's incorporated in the constants.
Okay.
Okay, so that gives us that our minus PG minus 1 PG is equal to minus 32.786.5. Or P1 gauge is equal to 33 kilopascal, and that is gauge pressure. You can also answer P1 is equal to 1013 plus 33. Which is 134. So that's absolute. Any questions on that? The key again is to define your system. Need a little break before we continue, so I will hold the problem sessions today. You wanna just continue, keep going and get out early?
So,
I'm fine with that. All right, so let's look at our next one then. Unless you had questions on that. Okay, so this is 432. And we have a strip chart now that displays the history of a leak in a storage tank. Okay, so we have so we have a liquid level meter or recorder, and it shows this trend. Okay, so we have the liquid height in meters in the strip chart, right? And then as a function of time. And we're told that there's no other, I know you might not be able to read that, but there are no other pumping or filling operations that occur during this time. The tank is 10 meters high and 10 meters in diameter, and it contains a liquid with a specific gravity of 0.9. Okay, so we're asked, when did the leak start and how long did it last? So that's just a matter of reading from the chart, right? When did it start? Kind of hard to see unless you actually have a straight line that you can put through here. So obviously the leak starts here because this is when it starts to go down. Okay, it's about 100 minutes. Okay, how long did it last? Roughly.
900 minutes. No.
I want to say this is the point where it levels out, right? See the nuke here? Because right here is where it comes out very quickly, and then it slows down, and about there, I'd say. So it's more like 1200, I want to say, right, when it levels out. So the way to do that is to draw a straight line from here, right, across, and just see where it starts deviating from that. Okay, so it lasted for about 1200 minus 100, so 1100 minutes. Right, so a little less than 10 hours. Right. Okay, what is the leak? What height is the leak?
2-ish.
Yeah, it's about 2 meters. Okay. So what's the total quantity leaked? Okay, that's another easy one, right? We know that it leaked out from 7 to 2 meters. 5 meters, we have the diameter, that's easy to calculate. But then we're asked to estimate the maximum discharge rate of the fluid and estimate the leak hole. The leak hole, like the whole diameter of the leak. Okay, so this is clearly fluid liquid through a hole in a tank, right? Where our HL0 is what? I have 1.7. Any other bits? 5. Remember, HL is defined as the height of the liquid above the leak, above the hole, right? So that was, I think, the only trick on the quiz, right? That you have to, HL is the height of the liquid above the hole. So it's 5 in this case. Okay, so obviously we have an equation for that. Let's look at what that is. In the meantime, you can think of another way to determine what the leak rate is. So I don't need to write down what the answers to A, B, and C was, or do you want me to do that?
No.
Just to make sure you have that. Oh, well, actually, let's do C. So volume leaked out is I times the diameter of the tank is 10 over 4, and then times 7 minus 2, just so we have that number. It is 392, 70, about 393 cubic meters. Okay, so max discharge rate. Is max is equal to area is the area of the hole, C naught, 2 GC over the road, plus do we have? Does it say anything? Filling operations, it doesn't say anything, right, about, that it's being pressurized. Okay, so if there's no information on that, that probably means it's vented, right? So, no info about PG. Okay, so assume vented, so we have PG is equal to 0. Okay, because that obviously
Rho is
simplifies
900, right?
the equation. We have
Rho
rho
is 900, right? That how it works.
0, and that is 0, so we get 2G
Oh,
HL.
yeah, 900 kilograms.
Left.
Alright.
Alright, so we have HL. Now we don't have the area of the hole. That makes it a little complicated now, doesn't it? Choose the time. Aha. I heard someone see that weirdly. We have the time, right? So what we can do is we can use the time to empty the tank, right? There's 1 CC area of the tank, or area of the hole, times 2G HL0, right? And what we have is delta T, which is time to empty the tank from, let me see, TE1 minus TE2. Doesn't really matter, right? But, right? And that is equal to, that's what we determined, right? 1100 minutes. Okay, so we know time to empty tank, we know our HL01, right? HL01 is equal to that, we've already said that, that's 5 meters. Okay, what about our HL02? Is it 2? Do I have any other bits? It is 0, right? HL is that, it's a trick question. I know, I'm sorry, I'm just reading. Right, it's the liquid above the hole. Okay, so if it hadn't all leaked out, then it would have been whatever, -2. But in this case, so that simplifies things. So our TE then 1100 minutes, which we probably should convert to seconds, 60 seconds per minute. And it is equal to, I'm gonna write it. Okay, so what do you think of C naught?
Doesn't really matter what it is, does it? Because you can just solve for.
Unfortunately, it does.
Well,
right?
you can solve for A of the whole times C naught as a total
Right.
constant.
Yeah, that's a good, yeah, that's nice. Right, right. You can solve for this. Absolutely. That's a good old switch. Okay, so now of course I hadn't done that. But since I'm running out of space, can I write it as D? So we have the area of the tank, maybe I should do that. Okay, we have, let me write this as, let me just give myself some more room. Maybe that's best than try to, instead of trying to cram it into everything. Oops. I should just be wearing